Hello viewers, welcome to shule.tv e-learning teachers project Uganda. This is Obonyo Kenneth. I'm back. This time round still with mathematics O level. And like we told you, all the work that you keep watching, we have that work on soft copy. You can always access it at any time for primary, O level, and then A level. You watch it from home as we try to kick COVID-19 out of Uganda. We also have a Facebook page, E-Learning Teachers Project Uganda. So tonight, I'm having some small topic for you. Remember the previous time we handled SADs. We finished SADs. Tonight, we are going to be handling what we call indices. The word is indices. Indices, like you see it here. Indices. Everyone, indices. Most of you have complications pronouncing some of these words. Indices. Now, what you need to know is the word indices is the plural form. Plural form. While when it is not plural, it is only one, then we are going to have it as index. This is the singular form. So when there are many, it is indices. When it is one, we say it is index. But what are indices? Can someone out there tell me what indices are? It doesn't matter from which district you're going to be calling from. I want you to call and tell me what are indices. If you feel like defining the index, it is okay as long as you help us, plus the viewers out there, to define what any one of the two words means. We have already learned that indices is the plural form, while index is the singular form. So someone has just called and said that all numbers in the form a to the power n, all numbers with the bases and the powers are in the form of indices, or they come from the family of indices. What am I trying to say? These are numbers with a base and a what? A power. I.e., they are in the form, which form are we talking about, Mr. Examiner, sir? We are talking about the form a to the power n. The a can be an x, it can be a z, it can be a p, it can be a q, it can be an r, it can be an s, any letter of the alphabet. Even n can be any letter of the alphabet, as long as we are able to indicate what we are seeing here. The examiner wants us to see exactly what you are seeing on the board here. But we need to go ahead and tell the examiner that where what? Letter A is what we call the base. Everyone, base. Base. A is what we call the base. And then N, you can call it the power. If you don't prefer calling it the power, you can call it the index. If you don't prefer calling it the index, then you can call it the exponent. Now, what does this mean? It means that all numbers in the form a to the power n, where a is the base, n is the power, or the index, or the exponent, they fall in the family of indices. Indices. So we have defined what indices are. Now, remember this power n here, some of you who study computer language, it is what we call a superscript. Remember, we have a superscript, which is a small floating letter or number in front of an unknown or digit. This one, which is floating up there, we can call it a superscript. When it is down, we call it a subscript. What am I trying to talk about? When you have, for example, a to the power x, this x here, you can say it is a superscript. While when you have a and then x down, we say this is a subscript. So we are trying to differentiate. So implying that in indices, we don't use the subscript. In indices, we don't use the second one. In indices, we use the first one. In indices, we use the superscript. In indices, we use the small floating unknown up there. In indices, we can give examples like we are going to give. Let us go ahead and say examples. Examples of indices. What are some of the examples, Mr. Examiner, sir? We need to look at the examples, some of the examples of indices. We have said these numbers have bases and at the same time they have powers. It doesn't matter whether the powers are positive or negative, whether they are whole numbers, whether they are decimal numbers, it doesn't matter. The powers can be any number. Even a zero itself can be any number. Now, examples. We can have example A. Someone should call me from somewhere. Yes, someone is calling from Luero. And is giving me an example of 2 to the power 3, which is good. That is correct. Another call. Yes, another phone call. Someone is calling me from Kumi district in eastern Uganda. Very good. Someone is telling me that another example is 5 to the power negative 3. It is okay. It has a base and it has a power. Though the power is a negative, but it is still correct. Another one is calling and saying, Mr. Examiner, sir, give me also an opportunity. We can have a 6 to the power negative a 7th. This one is a negative a 7th. Everyone, negative a 7th. Negative a 7th. Some are finding problems there. Negative a 7th. Good. So we have another example here. 6 to the power negative a 7th. Another phone call. Someone is calling from Kasese. Good. Someone is telling us that we can have another example like we can have a negative 2. Someone is giving us from Kasese. Remember, to the power 0. It has a base, though it is a negative base, and it has a power, though the power is a 0. It is okay. Those examples are enough. What we need to inform the examiner again is indices are able to show us how many times a number is multiplied by itself. I repeat, indices are able to show us how many times a number is multiplied by itself. What am I trying to say? This is what I'm trying to say. That if I have a number such as 7 to the power 2, 7